Okay, we are back for the third stream of the day in the structured programming class, and we're now finishing up the Koenig and Ritchie textbook. So we're not going to have homework as such about the last chapter anymore, but this is a very informative chapter. Even if you're never actually going to use Unix, most of the Linux variants do all of these things pretty much in the same exact way. And the same thing with the operating system on Apple computers, on the Mac OS. Things also work the same way. And many of these things work similarly in Windows. So section 8.1 kind of explains to you how do files actually work. When they talk about MS-DOS, that's kind of how it would work in Windows. And the way it works in Unix is pretty much how it works in any other thing. Section 8.2 will explain to you how is information written and read from files, like basically accessing the bytes. How do files open? How do files get created, closed, or unlinked in section 8.3. Random access is a way to read a file without reading it from the beginning to the end. You could basically just jump to whichever position you want to read. This is commonly done when you have like a proprietary file format and very large files and you need to access a certain field. So if you're going to be like a backend engineer, you're going to want to study section 8.4 eventually. 8.5 explains how we would use the operating system to implement stuff like opening a file or reading a character. So that's good low-level information to know as well if you're ever going to be a back-end engineer. In the same way, obtaining a listing of directories or files in a directory. This is also very helpful. This is something you might need to revisit if you ever take a class on operating systems, because this is a common thing and that you need to practice how to implement a file system, which involves accessing what are the directories and files present in your system. So many of this stuff is stuff that you don't really need right now. It's not like second semester kind of stuff, but it's the kind of stuff that's going to hit you on the face on the fifth semester if you're not actually aware of how this is working. In the same way, section 8.7 will be very useful when you're learning operating systems because this has to do with how memory will be reserved. Also very important if you're going to be doing low-level backend things at work. So I really recommend reading that. And you can easily practice by doing these exercises. A lot of people have GitHub repositories with their example codes for each one of these exercises, so you can look at those with great ease. Appendix A is something that you will probably going to be going through when you program in C or C++ or any similar language later on, because it's kind of a recap of the whole language. What are the reserved keywords? How do you define constants? How do character constants differ from numerical ones? How do you do string literals? How are expressions organized? What are the types one can have? How do we convert between types? And important information also on how do things like signed types and non-signed types work? How do pointers work? How do you generate them? How do you put expressions like the plus plus and the minus minus ones where you have things after the variable you are referring to? And pretty much every single operator is explained in the terms of what does it actually do. So this is good reading once you already understand chapters 1 through 7 at least. So you can look into technical details. So this is an appendix for people who already know how to program, whereas chapters 1 to 8 kind of like get you to the point of actually knowing how to program. And then after this Appendix A, scrolling down a little bit more, we have Appendix B, which instead of explaining how the language itself works, gives you the details of how the library works. So in our reference card, we have mentions of these different libraries, but this is just a little listing of what's in the library and how to call it. If you actually need to understand what do these things mean and how do these things work, The Appendix B is kind of like a longer version of the reference card that actually explains to you in higher detail how are you supposed to be using this. And then, since they sometimes make new editions of the book, there's a third appendix just to explain what changes are being made. The index is pretty useful if you need to find something in particular. Like, let's say we're interested in malloc and we'd like to know where in the book malloc would be discussed. Then I'm just going to look up here, malloc, the functions explained in page 187. The library function is discussed also in these 3 pages, so I can easily find content within the book. So I would really recommend keep the file at hand, keep the book nearby. Whenever you get confused about how something works in any programming language, revisiting how it works in C will help you refresh the conceptual understanding of how computers work in this particular aspect, and will make it easier for you to figure out how to do this in some other language. Like how does it work in Java? How does it work in Rust? How does it work in Go? How does it work in Julia? How does it work in Python? Because C is a kind of like a little bit of a lower level, closer to the computer kind of a language. So if you understand it in C, you're in a good starting point to understand it in some other language as well. So please don't throw away the book. Please don't throw away the reference card. Keep them at hand. And whenever somebody really wants to learn the program, make them read the book. I've been doing it for decades now, and I still believe it's a very good way for a cognitively functional adult to learn things. It's of course much easier if you had some pre-exposition to programming, which should actually be happening in most secondary and high schools by now. It's kind of sad that some schools don't really do it at all. And some schools only look at flowcharts. It would be very helpful, even if you're using like a toy language, to meet things like variables, conditions, cycles when you're a child, essentially, so that you kind of develop the conceptual understanding too later on. The important thing for us to do today is to start working on your individual projects, because next week, the ones that will actually want to do the project work will each give a little presentation on the topic. I will explain in a while how you do this presentation. You are not going to make PowerPoint slides. No one will make PowerPoint slides. We're going to use GitHub Markdown, and what you're going to be doing is you're going to be writing this in your repository in a file that's going to be called readme.md. You can either put it in the root of your repository, or you could make a subdirectory called something like project, and then put there the readme.md. So in that file, you're going to explain what you want to do your project on. If you have an idea, it would be pretty nice that we discussed it before we finish the class today, so I can kind of give you an idea of whether I think it's not too hard, not too easy, reasonable, something you can do. I would prefer the projects to be implemented using only the standard libraries here. So please don't use any other libraries. If you need another library, I'm going to need to hear a very good reason why you're going to be using that other library. I don't want you presenting somebody else's project that you copied from somewhere. That's very risky. That's going to end up with 0 points. What I want you to do is build the best thing you can to demonstrate what you have learned during the semester. It's better to have an honest self-made thing that's kind of limited than trying to pull off something that really is too hard, or simply you're going to end up copying somebody else's code. That's a very bad idea. So it would be nice that everybody picks something that's of interest to them and that's within reach with the skills that they have developed in the homework assignments, basing yourself on mechanisms and concepts that we have learned from the book, not something else. But before we dwell more on the topics, let me show you guys a little bit of how this README stuff works. So this is a repository of mine that you can use as an example. It's for a course that I might be giving in January. So when you go to a folder that has a README file, that stuff appears here beneath the listing of the files. You can put links in it. You can make like little lists. You can include images. You can include like little code fragments. Let's find an image. There's an image right there. So you can kind of like make a little web page by using this markdown in particular. And if you want to look at the markdown itself, well, you can just go to my README file and you could watch it raw. Because when it's raw, you can see what did I actually type because it's not rendering. So like if I want to make a link, I first put in brackets what I want to be as the text of the link. And then I put in parentheses what I want the target to be. I use stuff like pluses and asterisks to make a list. I use hashtags to make section definitions. I use this little Python thingy, kind of like in Discord, to insert code fragments. And let's find an image somewhere. There I'm just linking to code. This is where I'm linking an image. So this is my alt text for the image. This is the image file that I want to be shown, and it's actually coming from the same GitHub. So in this way, you will explain the topic of your project, and you will present a general design. So next week, you don't have to show any code. It might be nice to know what files you have planned. Like if there's going to be a header file, is there going to be one .c or several .cs? What subroutines do you have in mind? Do you need to define a structure of some kind? And possibly, if you would like, either a pseudocode or a flowchart explaining the structure, like how will your program work? You can draw diagrams by hand, or you could use some kind of a free tool to draw a diagram to explain what your project will be doing. I'm pretty sure I have here under the results of last semester. So you could go look at the projects that last year's people did. This person worked with a chess game, snake game, budget app, event organizer, calculator of the personal identifiers for Mexico, stuff for solar panels, labyrinth games, front desk thingies. So if you're interested in knowing what did they actually do, you can go to their repository. There should be a subdirectory for the project, and there should be a README file that explains how the project was going to work. And if you want to know which ones were the good projects, well, then you can look at the list here. How many points did they get in their project? And then you can try to identify the repositories. I'm not giving here the student ID, so you might have to do some clicking. I think this one was decent. Write in English if you're comfortable with it. If it's really difficult for you, just write in Spanish. I am not going to fail you if you have to write in Spanish. It would be kind of cool if you try to write in English. You can use Google Translate quite a bit too. So basically, what the people do here is that they explain the project. The auto evaluation part, that's when they are actually already turning in the project. So you don't have to write like a self-evaluation yet. You're just going to describe what's the topic for the project and how do you design the structure? Like, what do you think it's going to contain? Then the week after, you're going to show me a partial progress of the code. You're going to try to run the code. We're going to look at the code. We're going to estimate how much of what you said you would do, you're actually able to do. And you might need to update your design if it turns out that some things are just too complicated, or if the whole thing ended up being too easy and you want to make it more challenging. So next week, just what's it going to be on and the general design. The week after, first version of the code and updates on the design. And then on the 18th of November, you're going to present, you're going to show your code working. And what we're going to do there is so that you don't have to struggle with the live streaming of your code, you're going to make a little YouTube video and you're going to upload the video. And then you're going to put the link to the video into the README file so that we can go to your repository, we can look at your code, then we can click on the link to the video so we can actually watch the video of your program working, where you show that here I'm compiling it, now it opens this window, now I type these things, now this happens. So the demonstration that we're going to watch on the 18th, it's not going to be a live demonstration. You're going to upload it to YouTube. And if you have any questions on how to do that, we can talk about it either on the 11th or on the 4th. So for next week, we need the README files, hopefully with some diagrams of the design of what the project's going to be about. The week after, we need some code and some improvements on the documentation. And then 2 weeks later, on the 18th, we need the video, the code needs to be done, and the documentation in the README file needs to be done. So that's the plan for what we have to do before we're going to have the exam. So at this point, I am going to stop streaming and I am going to ask each one of the people who are actually interested in doing project work to please write on the channel, escriban aquí su idea inicial para el proyecto, because I want to make sure that we're not recycling the same exact ideas from last semester, that we're not proposing something that's really easy to Google and download from some site. I want them to be original projects. And I also don't want two people or more working on the same topic. So that's why I want to know, what do you think your project's going to be? If you really don't know yet, just type I really don't know yet, and then just let me know between today and the next class what the thing's going to be, so that I can tell you whether it sounds okay before you actually present the topic. We can also clarify any questions you have about preparing for the project on the channel. But I'm going to stop streaming now. I'm going to give you guys a recording of what we just did, and I'll catch you on the channel.